Hello, intermediate algebra students. This is Miss Lemitsky again, and welcome to your first lesson of semester 2. Today we're going to look at 7.4, where we're going to start talking about factoring polynomials, which is actually what we'll be doing for the rest of chapter 7. Having said that, today we are focusing on finding this thing called the greatest common factor. So before we begin looking at numbers and variables, we are going to start by using some pictures. Okay, I want you to pause the video and write down what you think group 1 and group 2 have in common. So what does this group and this group have in common? Hopefully what you found is that group 1 and group 2 both had 2 stars. So 2 stars. Hopefully you found that they both also had 3 smiley faces and 2 arrows. Okay, so if you understand this idea where you're looking at 2 groups or 2 lists of things and pulling out the things that they have in common, that's the first thing we need to understand when we're asked to find this thing called the greatest common factor. Okay, now that's pictures, that's easier to see. Now let's look at some numbers. Okay, so same idea, group 1 and 2, and again, pause the video and quickly write down what they have in common. So hopefully you saw that both group 1 and 2 had a 1. They both had a 3, and they both had a 5. Okay, so we had 2 lists of numbers, and we saw that they have a 1, 3, and 5 in common. This is going to be the strategy that we use when we start to find this thing called the greatest common factor. You'll want to get this down, that the greatest common factor, though, oftentimes we just write GCF. So when you see GCF, both today and in the future, I want you to make sure you understand that that means find the greatest common factor. Now, the greatest common factor, by definition, is the highest number that divides exactly into 2 or more numbers. Okay, so that's by definition what it is, but we need a strategy to be able to actually find the greatest common factor. And so that's where this bullet point's important. You can find the greatest common factor by making a list of the prime factors and then finding what they have in common and then multiplying those numbers together. Okay, so let's look at an example. We're going to find the greatest common factors of 12 and 20. So the first thing we're going to do is make a list of the prime factors. I like to use a tree strategy to do that. So I think about 12 and any 2 numbers that multiply to get to 12. So for me, I think of 3 and 4. If you put 2 and 6, that's totally fine. Okay, and then you keep going. 3 is a prime number. Remember, a prime number is one that only 1 times itself gets you to that number. But 4 can be broken down into 2 times 2. This means that for 12, the prime factors are 3 times 2 times 2. So it's a list of prime numbers that multiply to get to 12. 3 times 2 times 2 is 12. Okay, so that's my list of prime factors there, and then I go to the 20. And again, I think of 5 times 4. 5 is a prime number, 4 is not. So I break it down. 4 is 2 times 2. So then I could list these 3 prime factors for 20. 5 times 2 times 2 gets me 20. Now, I told you that warm-up we did will get us to the starting point of finding a greatest common factor. So the greatest common factor in this case, again, we make the list of prime factors. Technically, second, we find what they have in common. So we do what we did in the warm-up. Well, I see that both lists have a 2, so I put that as part of my greatest common factor. But then I see that they have a second 2 as well. The difference between this and the warm-up is rather than putting a comma between it, we are going to multiply any things they have in common together. So the greatest common factor of 12 and 20 is 4. Now, if we think about that definition, it said it's the highest number that divides exactly into both numbers. What that means is I can do 12 divided by 4, I get 3. I can also do 20 divided by 4, which is 5. Okay, so that greatest common factor is this number that both of those numbers divide by. And it's the greatest common factor because it's actually the biggest one. So that's our strategy if we're given 2 numbers and we're trying to find the greatest common factor. I want you to pause the video and see if you can find the greatest common factor of 14, 28, and 35. When you're done, unpause it and see if you got it. So we can do this with 3 numbers as well. I got 2 times 7. This one's 4 times 7, and that's 2 times 2, and this is 5 times 7. Okay, now make sure you keep your trees separated. Last time I rewrote the list, but you can also just focus on looking at the bottom of every branch. But here's the key. We don't use the 4, we have to use the 2's because they're at the bottom of the branches. Okay, so those are the things I'm looking at, and all 3 lists have a 7. At first I see a 2 in 2 of the lists, but it's not in this one, so 7 is the only greatest common factor. If there's only one number they have in common, you don't have to multiply. Now the second part of this example, or the second example on this slide, shows that we can use the same strategy with variables. Now, if I have x to the 8th power, remember, x to the 8th power means I'm going to multiply x by itself 8 times. Okay, that's the first one. Then I take x to the 6th power. That means I'm going to multiply x by itself 6 times. And finally, I have x to the 5th power. Multiply that by itself 5 times. Now, if I follow the strategy of finding what they have in common, I would circle an x. So I'd write down, okay, the GCF is x. I would circle another x because they have another x in common. Circle another x. They have another x in common. A fourth one. And finally, a fifth one. I'm out of x's in x to the 5th, so I can't find anything else in common. Remember, once we list out everything they have in common, we multiply it together. And x times itself 1, 2, 3, 4, 5 times is x to the 5th power. So the GCF in this case is x to the 5th. Now maybe you noticed that did happen to be the exact same as one of our original x's, and it was x to the smallest power. So as you continue practicing this more and more, you might figure out some things that make your job slightly more efficient. For example, I could have grouped all of these together and said I'm just going to take 5 x's out of each. Okay, you may even get to the point where you don't even have to write your x's out, but it's always a strategy for you. All right, let's try the top one here together. Okay, so this one shows that you can have a combination in these of numbers, variables, and in this particular case, more than one variable. Okay, if I have that, I just think of it piece by piece. First, I deal with my numbers. 25 is 5 times 5. 30 is 5 times 6. Now, here's another efficiency. I could stop there, okay, because I see that they have 5 in common. Okay, so my GCF is going to have a 5. And I could break down the 6 as 3 times 2, and I'm going to show it this time. But because I knew that I couldn't turn the 6 into a 5, I could have actually stopped. So there's, again, going to be times where you can be a little more efficient, but you don't have to. All right, then I'm going to write out my 3x's for the first one and my 2x's for the second. And so again, if I go 1 for 1, I have 1x, put that there, and another x, put that there. Again, you may have just been able to write x squared because you recognize that it's the smallest one. Or you might have seen that you took 2 out, so you just write it as x squared right away. Either strategy works. Last but not least, I have 5y's here and 10 over here. Now this is why you want to probably start getting to the fact where you're seeing these patterns. So I continue to write them down, but again here I'm going to say, okay, I have 5 here, and 1, 2, 3, 4, 5 here. So I'm just going to take out y times itself 5 times, so it's y to the 5th. Okay, so I showed on the y's how I could do this a little bit quicker. Okay, so my GCF is 5x squared y to the 5th. Now again, if I had like y to the 28th, I would not want to write out y 28 times. So that's where you want to start to save yourself some time. All right, I want you to pause the video and see if you can find the greatest common factor of these 3 terms that have 3 variables. Hopefully, as you saw it, again, if I was going for efficiencies, I see x to the 5th, x cubed, and just an x to the 1st. So you may have recognized that if the third one only has a single x, it can only be 1x. Or if you wrote out all your x's, you would see you could only circle 1. Okay, same thing with the y's. If you look at the exponents, 2, 1, 3. Again, there's only 1 in common. I could write them out, y, and 1, 2, 3. But again, once I have those lists, I see that there's only 1 y on each list. And finally, when I look at the z's, the first one has just a single z. Therefore, as long as they all have a z, There's 8 here. You may have written them all out, but once again, you would see there's only 1 on each list. Okay, so hopefully, again, with these variables, you're starting to save yourself a little bit of time and seeing that it's always the smallest exponent one. All right, last but not least, the only other thing you're going to see today, here we just listed 2 different things that we're finding the GCF of, or 3 separate things. We put either commas or ands between it. Ultimately, we're working towards dealing with polynomials with these greatest common factors. This is just the first step to find it. Tomorrow, we're going to figure out how to factor out the greatest common factor. So the last thing we want to talk about is, okay, this is really what we're going to be seeing. Okay, so we're going to see polynomials, which means they're going to have pluses and minuses between them. So when we do that, we just want to make sure that we're still able to take those 3 terms and find the GCF. Okay, so if I'm given this problem, again, I do it the exact same way. 12, I'm going to stick with my 3 times 4, which is 2 times 2. So I'm looking at these 3 numbers, and then I have 5 x's. Then I deal with 8, which is 2 times 4, which is 2 times 2. And this one had 4 x's, but then it had these 3 2's. Now, negatives we're going to talk a lot about tomorrow, but if you have a negative, you may want to write it now as a negative 1 times 6. Gives me 3 times 2, and then this one has 3 x's. So when I go to write my GCF, again, I look at these 3 lists, and again, I have these underlined numbers. And right now, I have a 2 on each list, and that's actually it. Okay, at first I thought maybe I had another 2, but this last one didn't have one. Okay, so I have a 2 on each list, and then I had 3 x's. So x times x times x is x cubed. So 2x cubed is the GCF of that. Again, tomorrow we're going to take it a step further. We're going to talk about what we do with these things that are still left on the list. And we're going to use those to factor out the GCF. But today we just need to be able to find it. All right, let's do one more together, and then I'll set you free. If you're feeling good about it, though, pause it here and try this and check your work. 18 I had as 3 times 6. Now I'm going to show you how I can save a little bit of time, because this is 1 times 6. This is 6 times 4. So if I recognize right away that all 3 are divisible by 6, I can make that a factor of each of them right away. Okay, so there are times I personally don't use greatest common factor. I mean prime factor, sorry. But if you want to, you can always break it down. Okay, so if I break it down, this one has 4y's, 3y's, 2y's. When I go to write my GCF, okay, so I'm going to ignore these circles that I put around here. So I went all the way down to the prime factors, and I noticed that this, and this all have a 2 in common. Oh wait, this is supposed to be 2 times 2 again. And then I also noticed they all have a 3 in common. So they have a 3 and a 2 in common. Remember, we multiply. And then again, we have 2 y's in common. This time I'm going to write it times y for those of you who aren't quite seeing it. And now I multiply these together. 3 times 2 is 6. Y times y is y to the 2nd power. Okay, so my greatest common factor of this one is 6y squared. All right, last but not least, this one I do want you to pause and make sure that you're trying it. And then we are going to go over it. All right, so 15 is 3 times 5. Those are both prime, so I have 2 x's. A negative 18, so I can do a negative 1 times 18. And then I can do a 3 times 6. If I want to break it all the way down, 6 is 3 times 2. And this has 1x. Now I look at my 2 lists to find my GCF. The first number that I see they both have in common is a 3. This one just has a 5. This one has a negative 1, a 3, and a 2, so nothing else matches, but we'll use those tomorrow. Finally, they both have a single x. This one still has an x left, this one doesn't, but I can't take anything else out. So you should have had a greatest common factor of this one of 3x. Okay, so that's an introduction to this thing called greatest common factor. Here's the note sheet I made, a 1-page note sheet. So if you want to take a look at that, make sure you have down what you need. Otherwise, you should complete and submit your 7-4A Pearson practice now. Thanks, and we'll see you tomorrow.